Okay, in this section 7-3, we're talking about parallel lines and proportional parts. And there's two theorems that we're going to look at in this section. And the first one says, if a line is parallel to one side of a triangle and intersects the other two sides, then it cuts those sides into proportional parts. And so if we have a line here, and we know it's parallel to this side because of these two arrows, that indicates that the two segments are parallel to one another, then it must cut these other two sides into proportional parts. So let's say this piece is 8, 4, 10, and 5. Okay, so those pieces have to be proportional. So in other words, if I put 8 over 4, that divides out to make 2, and 10 over 5 also divides out to make 2. Those fractions that you make with those parts, they have to be the same. All right, let's see. Also, if I have another segment that's parallel to this side of the triangle, and let's say it hits right at the midpoint of each one of these other sides. So remember, that's called the mid segment. And so if both of these sides are the same, 5 and 5, all right, so 5 divided by 5 is 1. And if both of these are also the same, 8 and 8, that's also 1. So it still makes them proportional when it's parallel. But here's something else that happens. If you've got the mid-segment, the mid-segment will be exactly half, okay, the length of that side that it's parallel to. So if this has a length of 6, this has got to have a length of 12. But remember, it only happens if this parallel segment is the mid-segment. All right? And you can tell if it's the mid-segment is if these two pieces are the same and these two pieces are the same. Then this will be twice as big as this, times 2. Okay? All right, here's the second theorem that we're going to be looking at. It says if 3 or more parallel lines intersect 2 transversals, then they cut the transversals into proportional parts. All right, so this time 3 or more parallel lines cut 2 transversals. So here I've got 3, and here are my 2 transversals. 3 parallel lines, 2 transversals. Then they cut the transversals into proportional parts. Right? So in other words, here are 2 parts that it's cut into, 6 and 8. Here are another 2 parts, 9 and 12. Well then, this fraction, 6 over 8, is the same as 9 over 12. They both reduce down to 3/4 or 0.75. Okay? So again, if you've got 3 or more parallel lines, it must cut them into proportional parts. And if you've got more than 3, like if we had another one down here, then this piece over the third piece down here would be the same as this piece over this piece. All right? And you could actually even kind of ignore this line in the middle and add these two together. So these two added together over the third one would be equal to these two added together over the third one. So it works for any 2 sets of proportional parts that you want to put together and create fractions out of. All right? So those are the 2 theorems that we're going to be looking at. And here are the types of problems that we're going to be asked to do. And so, again, I've got a triangle here. My task is to find x. But look at the scenario. I have a parallel line, or excuse me, a line that's parallel to this side and hits the other 2 sides. Well, that's what the first theorem says, that it cuts these into proportional parts. And so what that means is I can make this as one fraction, x plus 22 over x plus 2, and I can set it equal to the other fraction, 18 over 6. So again, if this is parallel to one side, then you can create fractions out of each of those other 2 parts and then set them equal to each other. They must be proportional like we've done here. And now we just need to solve it. Do the cross product, 6 times x, 6x plus 6 times 22, which is 132. And then the other cross product, distributive property again, 18 times x, 18x. And that's going to be a plus. 18 times 2, 36. 6x minus 18x. Can move the 18 over, change it to minus. Equals to 36. Bring the 132 over, change it from plus to minus. And we'll subtract here and get negative 12x We'll subtract here and get negative 96. Ready to divide by negative 12 by negative 12. And we come up with x is equal to 8. And then there's your answer. Okay? So again, all we did was we took and we used the theorem to create the right proportion and then solve it for x. And likewise here on this one, we can do also a similar procedure. This time I have this segment parallel to this side of the triangle. So again, I can use the same theorem that I just used. And the theorem says that this parallel line now must cut these segments into proportional parts. All right. So when we go in to look at this, okay, here's what we need to kind of keep in mind. I can write this piece over this piece as my first fraction. So I'll write x plus 4 over 27 equals. Now, here's the thing I want to remind you of. Whenever you're creating proportions, you must use the same pattern every time. Okay, you can't use one pattern for one fraction and a different pattern for another fraction. Okay, it will not give you the correct equation. And plus, if we're going to utilize the theorem tells us which parts to use. We have to use this piece over this piece, right? And then for the other one, we have to use this piece from here to here, which is 16, okay, over this piece, which is not 34. 34 is the whole thing, right? So I can't write 16 over 34. That's not the right fraction. It'll be 16, this piece, over this blank piece. All right? Now, it doesn't tell me how long this piece is, but I can get it. If from here to here is 16, and the whole thing is 34, how am I going to get this piece? Well, I need to do 34 minus 16 and get 18 right here. All right? So just be careful when you're making your proportions that you are using the same pattern to get both of your fractions. This piece over this piece equals this piece over this piece. All right, not the whole thing. So be careful with that. Now we're going to write it out. It's going to be x times 18, which is 18x, plus 18 times 4, which is 72, equals to 27 times 16, which is 432. Then so now I'm going to move the 72 over to the other side. That's going to be 18x is equal to 432 minus 72. Got to subtract it off. 18x is equal to 360. Now we're ready to divide that by 18. And of course, when we do, we get x equals 20. And then that is your correct answer right there. Okay? So again, it's all about making sure that you get the correct fraction, write out the correct fraction. Okay, so now this next problem is where we will use that second theorem that we looked at. We have three parallel lines cutting two transversals, right? And so it cuts them into proportional parts. So my first fraction is 10 over 2x plus 5, and I'm going to set that equal to the other fraction, which is going to be 12 over 18. Okay? So now from here, I can go ahead and do my cross product. 12 times 2x is going to be 24x. Oh, man. Plus 5 times 12 is going to be 60 equals 10 times 18 is 180. All right. So now I've got 24x is equal to 180 minus 60. 24x is equal to 120. Divide both sides by 24 and 24. Then now we have our correct answer, which is that x is equal to 5. All right? So again, when you go in to do your quizzes, you can use those two theorems to set up the problem, solve for x, and you got it.